Hello there, welcome back to the shed. This is a video about DCC control of points. So specifically we are looking at the Cobalt Digital IP point motor, and we're going to go through what you get, how much it costs, how to wire it up, how to fix it to the layout, and any sort of additional extras that you can do with switches and LEDs. Now I have done a video before on DCC control using the SEEP point motors, but obviously this one's about the Cobalt, so there are a few bits that repeat from that old video, but that was 4 years ago, so I wanted this one to sort of stand on its own. So with that in mind, let's take a look at what you get. I've been buying mine in packs of 12. You do get a slight discount and they come in a box like this. They're about 20, just under £20 each, but as I say, if you buy them in bulk you do get that reduced slightly. So let's take a look at one and fit it together. We get a nice little owner's manual with all the instructions inside. For each point motor in the box you get a sticky pad and all of the fittings to fit the motor to the baseboard and to move the point. Have a look at those, and of course the point motor itself. And that's where you put the wires in. So the first thing we need to do is a tiny little bit of assembly, and that's simply attaching the rod through that to the point motor, and there should be a little screw to secure it, so let's do that. We'll do, just in preparation, is just stick the sticky pad on ready, and so that's all the actual assembly that you need to do on the point motor. Now the basic wiring for the Cobalt point motors is very simple. This is just set up to show you. So you've got your DCC system, whatever system that is, and you've got your two buzz wires coming out the back, and you'll have your dropper wires connecting up to power your track. All you need to do is have a couple more dropper wires, strip off, and these are very handy for doing that, about 10mm, so quite a lot of a decent amount of bare wire at the end there. Just give it a twist so it's easier to slot in, and to connect it to the actual Cobalt point motor you just put it into the DCC in ports, the first two ports. Make sure it's not upside down. They've put this sticker on now to remind you and make sure you do get the power going into the DCC in ports. If you put power into here, you will probably fry the inside. So that's why they added this warning, and that is very important. Never supply any power to this end. It goes in the first two there. So you literally just press down that and slot the wire in. And that's really secure. Make sure you got no bits of wire sticking out, but that's easily done. just give them a twist to make them neat. That's it in terms of the basic wiring. There's one other easy additional bit of wiring you can do, which is the third port along, which is frog. That's labelled frog. So you put a wire from the third port to the frog point, which I'll show you on the layout, and that will power your frog if you've got electro frog points. I'll just quickly show you how to program the point motors up quickly, because it is very, very simple. Whatever your DCC system has to do to trigger the point motor changing from one side to the other, you simply need to slide the switch on the Cobalt to set, press whatever you need to press on your DCC system to trigger it, switch it back to run, and that's it. So for example, if we want this to be address 75, we go set, and that's one improvement over the previous version. The switch is much bigger and a lot easier to switch. So once that's in set, that's how you would switch a point on the Hornby Select. So you do whatever you need to do on your system. Back to run. And there it is. So the whole system, the DCC bit, is all inside here. It's all one unit. And that also allows you to change the frog polarity as well. Now, a bit of a bonus feature. There are other things you can do with these point motors other than DCC control. So here you can see I've got a simple push button switch temporarily rigged up to the left and right ports on the push button ports. And if we push the push button, we can activate the point motor that way. You could also have two push buttons and just use the common terminal connected to both buttons, and then left and right to one each. So you could have a push button for left and a push button to throw it to the right. You could also use a normal switch with these switch ports. You can also have LEDs, so you can have an LED that lights up when it's thrown one way and a different light when it's thrown up the other way. You can interlock them so that the two point motors are sort of interlocking, and you can't cause a train to go down a point and sort of short circuit because it's the wrong way. So you can interlock them to prevent that. All kinds of things that you can do, and using this you could build, as well as having DCC control, you could build a sort of manual control panel as well. This is the point we're going to be motorizing, and underneath here, so this is the frog, there is a wire I've already soldered on, so I'll show you that in a sec. The only other thing to say is you'll notice that this point moves very smoothly. That's because here there was a tiny little spring which is now there, which you just need to get some tweezers and just prise it out so that it doesn't click from side to side. It's nice and smooth. That helps with the sort of switching of the frog polarity. So as soon as the point motor starts to move, it disconnects here and you don't get short circuits, and it also looks more realistic that it's sort of smoothly sliding along rather than clicking from one side to the other. And underneath the point, we can ignore all this. This is just dropper wires going to different bits of the track. All we need to look at is we've already drilled a hole for the metal bar to go up through the baseboard, and it's just this wire connected to the frog because it's the only one not connected to anything at that end, so that will go into the third terminal. So let me show you how I fit them to the baseboard. So now we're first going to connect the wiring, as I showed you in the sort of mock-up. I use these, they're called T-tap connectors. You just find your buzz wire, crimp it on, and then you get your dropper wire, crimp it onto the connector there, and then just once that's crimped on, you just plug that in there. It saves soldering. So let's get that connected up. So we're connected up. I've given it a quick test. So now what I do to fit them is simply peel off the sticker and gently stick it in place, give it a test first, and then if it's all working, just drill some little pilot holes and screw it in place. So all that remains now is to obviously nip this bar off, level with the point so that it doesn't snag on the loco wheels as it comes past. And give it a test. So in summary then, I really like these point motors. They're probably not the cheapest option, but I like the fact that they're all in one unit and they've got so many options. They're really flexible. The IP version improves the gearing inside. That's been redesigned, and the electronics have been redesigned. The IP stands for intelligent power apparently, and it will take 7 to 23 volts. AC, DC or DCC, so a lot of flexibility on the input voltage to power these things. And yeah, I'm just reporting my experiences with them. I've used probably 25, 26 of these now. I had one that was kind of dead on arrival, just didn't work. I had to swap that one out. But apart from that, I've not really had any problems with these. I've been using them for a few years now, and yeah, it's all good. So if you have any alternatives, let me know in the comments. Let me know what you use and what you found. But for now, thanks very much for watching. I'll see you soon.